All right, we're going to take a stab at 3.1, solving problems with fractions. Okay, but before we get into that, let's try a couple of warm-ups. 1 divided by 7/8. Well, the fraction, or the number 1 is the same as 1 over 1 because any number divided by 1 is itself. So we're talking about 1 over 1 divided by 7/8. And what we learned in the getting started part of the chapter is that when we are dividing two fractions together, we multiply the second fraction by the reciprocal, or the first fraction by the reciprocal of the second one. So we can say 1 over 1 divided by 7/8 is the same as 1 over 1 times 8 over 7, which is equal to 1 times 8 is 8, and 1 times 7 is 7. So it's 1 divided by 7/8 is 8/7, or if we want to convert that to a proper fraction, 7 goes into 8 1 times with 1/7 remaining. Okay. Number 2, 3/8 plus 1/16. Well, we have to find a common denominator between 8 and 16 when we're adding, and that is the number 16. So we can say that this is 1 number over 16 plus 1/16. So 8 times 2 gives me 16. So 3 times 2 is 6. So 6/16 is equivalent to 3/8 plus 1/16. We have the same denominator, so we just put the answer over 16. We add the top two numerators together. We get 6 plus 1 is 7. Okay. Number 3, 3/4 divided by 1/8 is the same as 3/4 times the reciprocal of 1/8, which is 8 over 1, which is equal to 3 times 8 is 24, and 4 times 1 is 4. We can simplify this fraction because we know 4 divides equally into 24, so this is the same as the number 6. 1/4 times 7/8, well, this is simple. Multiply everything on the top by everything on the bottom. 1 times 7 is 7, and 4 times 8 is 32, so our answer is 7/32. We can't simplify that. It's as low as it'll go. Okay, so there's some warm-ups for you. Let's do a problem. Katie is a cabinet maker. A client wants her to build this cabinet with equally spaced shelves. In other words, she wants the spaces in between here to be all the same. Okay? She plans to use 3/4 inch birch plywood. So how far apart are the shelves from the bottom of the shelf to the top of the next? So we want to know the distance from here to there. Okay? So how do we do that? Well, let's go through the procedure. Number 1, how many boards will Katie need to build the top, the bottom, and the shelves? So we count the top, the bottom, and the shelves. So there's the top is 1, shelf here's 2, another shelf 3, another shelf 4, another shelf 5, and the bottom is 6. So we know we're going to be needing 6 boards. If each board is 3/4 of an inch thick, what is the total thickness of these boards? Well, we take the number 6, multiply that by 3/4. Okay, well, that's 6 is the same as 6 over 1. Multiply the top, 6 times 3 is 18, and the bottom number, 1 times 4 is 4, so we have 18/4. Okay, so let's convert that into a proper fraction. 18/4, well, 4 goes into 18. How many times? Well, it goes in there 4 times. Okay, which 4 times 4 is 16, and we have 2 left over. We have 2/4 as a fraction, and 2/4 can be reduced to 1/2. So our total number of thickness for our shelves and our top and bottom is 4.5 inches. Okay. Number 3, how much of the cabinet height is left for the space between the boards? Well, the total height is 7 feet 3 inches. We want to subtract 4.5 inches. So how do we do that? Well, 7 feet 3 inches, we want to convert that into total inches. We know that there's 12 inches to a foot, so 7 times 12 is 84. 84 inches and 7 feet. We add 3 to that. 84 plus 3 is 87. So we end up with 87 inches. And we want to subtract 4.5 inches. And 87 subtract 4.5 leaves us with 82.5 inches for our spaces. How many spaces are there between the boards? Well, let's go back and let's count the spaces. We have 1, 2, 3, 4, 5 spaces, and now we know we have 5 spaces, and we have 82.5 inches to divide equally amongst 5. So how far apart should Katie put the shelves? Well, we take 82.5 and we divide that by 5. So we can take our calculator here, and we can take 82.5 and we divide that by the number 5, and we get 16.5. So our answer is in inches. So Katie should put the shelves 16.5 inches apart. And if you want to build anything, these are the types of problems that you're going to be facing, okay, as a cabinet maker or as a carpenter. Let's do one example here involving a baker. Caden is a baker. He cuts a 14.5-inch roll of dough into 1 1/4-inch slices for cinnamon buns. How many buns can he make from one roll? Well, how do we do that? What equation can you use to solve this problem? Well, the number of buns equals to 14.5, and how do we know how many he can make? Well, we need to divide that by 1 1/4. Okay, so it says rewrite the equation using improper fractions. 14.5, so because we have to take 14.5, we have to divide that by 1 1/4. The best way to do that is go from proper fractions to improper. So the first one, 14.5, we take 2 times 14 is 28, plus 1 is 29. So 14.5 is the same as 29 over 2. Divide that by 1 1/4. Well, let's convert 1 1/4 into an improper fraction. 4 times 1 is 4, plus 1 is 5, 5/4. So we have 29 over 2 divided by 5 1/4. How do we do that? Well, that's the same as 29 over 2 times the reciprocal of 5/4, which is 4/5. Okay? So we know that when we're multiplying fractions, we multiply the top, we multiply the bottom. So 29 times 2 is 58. 29 times 4 is, well, let's take our calculator. 29 times 4 equals 116. So our answer is 116. 2 times 5 is 10. So we have 116 divided by 10. And if we want to just find out how many buns that he can get, we just take the bottom number, divide it into the top number, because we can only have an even number of buns, and we're going to have a little bit of dough left over. 10 goes into 116. How many times? Well, we can get 11 goes in there, 11.6. But we can't have 0.6 of a bun, so we know that Caden's only going to be able to get 11 whole buns out of that roll. And he's going to have a little bit left over that he's probably going to have to do something else with, okay? So we can say Caden's going to make 11 buns, and he's going to have 0.6, or about a little over half of another bun, okay? You guys can go ahead and try example number 2, and then work on the practice.